Hi, um, hello, good day everyone, and welcome to another wonderful session. Today I've been talking about Siemens PLC hardware. This will be the part one video, and I'll make another part two where I'll show you some devices, Siemens devices. But this part one, I want to introduce you to general PLC hardware. I titled this Siemens PLC hardware because we'll be talking more about Siemens, but before we go into Siemens, I'll just show you some uh, general topics from other manufacturers as well. So before we go into that, I just want to quickly show this. I've created a GitHub repository for this training purpose, and the main idea is to share documentations, notes with you using this. I noticed that quite a few of you had issues with the OneNote. So with a GitHub, you shouldn't have that problem. Also, I wanted to introduce you to start using GitHub because many of you, once you go into organizations, when you start working, many organizations use GitHub now. So either you go into a complete software development organization or any major organization, GitHub is what almost everybody does use now. So I wanted to introduce you to that. And also, if you don't have a GitHub account, just create one. I'll put the link of this GitHub repository um, in your group. I'll also add it to the video comment, the video description, so that you can always have reference to it. So my idea is to share documentations with you using this. We've already had discussions on resources. We've already had discussions on introduction. We've already had discussion on TI portal installation. You can always go in here to pick the documentations. So right now we're discussing PLC hardware, which I said will be in two different videos. In this PLC hardware, I've also included some documentations, a simple production process, which I would like to use as a description for this training. I'll make some references to this, at least just to give you some idea. If we go back, if you go, there's also a documentation here, ABB PLC system specification. If you're not able to open this directly, I've added the link to this docs.md file. So one of the first things I want us to check first is, okay, let me start from number 3 here. So the first thing is I want to show you the ABB PLC automation hardware manual. And with this, it opens up a PDF. With this PDF, I want to familiarize you with some things. One of it is, as a control engineer, when a PLC is sitting in front of you, what do you see? What do you understand when you look at a PLC? So when you look at a PLC, you should be able to first understand documentations. You should be able to know what you're looking at. You should be able to identify parts. For example, when you look at this documentation, you see it's titled 1, 2, 3, 4. And then you can see here that there are some notes that are here. IO bus, female connect, things like that are listed there. So, one moment, please. IO bus. And I've told you earlier, IO means input and output. And when you look at this diagram, it's showing you this is the input and output bus connection. Number 2, it says one available slot for processor module. Here, basically, when you look at all of this, you should be able to identify what you're looking at. Number 7 says RJ45 female connection for Ethernet connection, which is this. So all PLCs have similar architecture. We already discussed this in the last video, where you have inputs, outputs, you have the processor, you have connection and power connection, communication ports. The most important part I want to show you, part of it is this. So here you have the power supply on this PLC. It says the power supply voltage is 24 volt DC, connected to a removable 5-pin terminal block. So it's saying when you look at this PLC, you see something like this. You see something like this, and it's showing you L plus M and earth. Here, L plus means 24 volts connection, right? And here we have two L plus connections. So you also have two M and one earth. Usually in the control engineering world, we usually have what we call redundancy, which means when a power supply fails or when something fails, in this case, we're talking about power supply. When something fails, uh, we should always have a backup plan. In this case, this PLC has two power supply connection ports, which means you can have two separate power supplies that are supplying power, in this case 24 volt DC, to this PLC, which means if one of the power supply fails, the other power supply comes into play and this PLC keeps running. In some cases, you only have one connection to the PLC. However, you have another module where the two power supplies are connected to, and that module does the switching from those power supplies to the PLC. Another part is, yes, this communication port. So when you see something like COM1, COM2, you should have an idea, okay, this is a communication port. And then you can read through to understand what type of communication, what port is communication. You also have the RJ45 connection, which is not broken down into 1 to 9 like this. This is what I meant. This RJ45. So RJ45 is basically your Ethernet ports, just like you have on your laptops, on many devices that sits around you that you see on day-to-day basis. We call it RJ45 in the industry. So basically, you should be able to read documentation manuals and all those things that you see here. I'm showing you an ABB manual are the similar things that you will find on different manufacturers as well. Siemens, Beckhoff, different manufacturers, like I mentioned. Now, if I go back here, one of the major things I want to show you is Siemens comparison list. I want to show you Siemens PLC ranges, which is what I want to discuss in full on the second video. But here I can just briefly show you. So if you look through this document, you will find the Siemens PLC ranges over the period of time. You have S7 300, S7 400, S7 1200, S7 1500. S7 Simatic 7 is what Siemens calls this their current range of PLC products. If you read through this document, it shows you the differences between these PLCs. For example, it says overview of data types. Data types is also what we'll discuss later. And it says on S7 300 you have Boolean, byte, word, double word up until this date. Only S7 1500 can deal in L word. You understand? If you also try to see maybe something different, let's see. Um, okay, there's something here. Okay, so here it's telling you if you're discussing maybe basic instructions, here you have greater than or equal, comparative, you have comparative, less than or equal, greater than, less than. All of the PLCs can do that. But when you want to check if the value is in range, out of range, if the value is okay, not okay, only the S7 1002 and S7 1500 can do this. These are some differences that you start to notice when you start to program, when you want to program. So as a control engineer, you should know what kind of engineering you're trying to do, and with that, you should then be able to choose the right device for you. I have an image here that I quickly want to show you. Yes, this one. So, this is S7 series PLCs over the years. Many of you might be familiar with logo. You might also not have heard about it. S5 was the PLC product range before Siemens developed S7 product range. So you have the S7 300, you have the S7 then 400, and then Siemens developed the new modern ones, S7 1000 to S7 1500. Currently, S7 1500 is the top range of PLC products, and the S7 1500 is able to do all programming functions that you might want to do now, just like we saw in the documentation earlier. You can also look at that to give you more information. If we go into the doc mode, I saw a Siemens online document that I would like to discuss with you. Here you can read about the configuration for PLC. I discussed with you earlier about power supply, CPU, and some extra modules. Now, this documentation tells you some information or major information that you need to know as a control engineer. For example, I told you before now that you normally have a rack. You normally have a rack, physical rack, but also you have a software rack where you place the devices into. There are limitations. I mentioned, and if I didn't before now, the power supply usually takes the position 0 in your configuration. You cannot put it anywhere else. It takes your position 0. Your CPU takes your position 1. Then any other module can take between 2 and 31. In this case, it says it can only take maximum of 32 modules. If your programming or your engineering requires you to have more input or output, then you look for something which we call expansion module, which allows you to connect one rack like this to another rack. But that's not the case for now. So if you look at this documentation, it tells you that your power supply can be in position 0, only one power module can be configured in step 7. You have the power supply, PS 0, and then also permissible from 2 to 31. You can have 3 power supplies. Power supplies are the ones that you can put in between these racks. For example, if you want to add more power on the bus, which I'll also show you later. The CPU is usually in position 1. Analog and digital IOs can be from position 2 to 31, and then you have communication modules as well. Basically, that explains that. However, you can also have a system where you don't need to include your power supply in position 0. So for example, you have a 24-volt power supply sitting somewhere in your control panel, and you just take the 24 volts from that directly to your PLC and then your modules. So it doesn't need to be on the rack as long as you supply the required 24 volts to the system. So meaning this power supply then is optional in this case. Now, one of you asked the question some time ago, how to know if the PLC's power is enough for all other devices on the system. Number one, before you can power the other devices from the CPU, in this case, in this way, for example, you want to take power from the CPU to the other modules, you need to configure this. You need to enable this in your settings. We will also show that when we start going into the software, which says you allow to set up the supply by means of CPU interface, connection to supply voltage. Or if you don't, Then you have to click no connection to supply voltage, which means these modules, the next modules that sit beside the CPU, cannot take power from the CPU. They take power from external power supply. When you do these connections, you should have an overview page where you see the basic power consumption on the line, the power supplied and the power consumption. In this image we're looking at, we have a power supply supplying 25 watts, which is shown here, which sits on slot 0. And then we have the PLC slot 1, which also supplies 12 watts, because the PLC is able to also generate some power supply. It consumes and it also generates a little. In total, for this system, you have around 37 watts. Then it shows you the devices on the other slots and what they consume. This digital input module sits on slot 2 and it consumes 1.1 watts. The digital output, which is a DQ, sits on slot 3 and it consumes 0.8 watts. The analog input module sits on slot 4 and it consumes 0.7 watts. An analog output module sits on slot 5 and consumes 0.6 watts. In total, you can see what is generated and what is consumed, and then the summary is 33.8. It then says, when you check this power segment overview in your software, if the power balance is negative, then the step 7, which is the programming interface, marks the underpowered modules in red. It shows you in red, these guys are not able to get power from this system. Either you supply a higher rating power supply or you connect them to external 24-volt power supply. So if you go through this documentation, you should have a very good information about your hardware, which I want you to not just jump into the programming. There is something I also want to show you above. Yes, this one. So the TIA portal that you've installed during our third lesson has different parts to it. There's the Siemens Step 7 Professional, Siemens Step 7 Safety Advanced, Synamics, Symatic Win CC, which deals with the HMI. In our case, we'll be focusing majorly on Step 7 Professional, hardware configuration, parameter assignment, networking, programming with these main 5 programming languages. We will be doing, I think, 2 or 3 just to show you. Our major focus will be on ladder, but I would also show you how function block and statement list can be used. We wouldn't do any trace, motion control, diagnostics, but basically I can show you some bits about this. So I want you to take your time. Go through this Siemens online manual. It's very, very good. I also just came across it myself, and I wanted to share this with you so that you can have a good time with this. So then we can go into hardware discussions. If you don't have any questions for now, if you do, you can ask me, and if you don't, then we can directly go into hardware discussion. So before we go into our hardware discussion, let me also quickly give an overview of what I have here. So I want to use this as an example to share um, some industrial experiences with you. What I have chosen is a simple production process line. In this case, let me say a food and beverage production line. So we have a filling machine, we have a conveyor, we have some bottles on the conveyor, we have a control cabinet which controls this process. We have a PLC inside of the control cabinet, and then we have an HMI which sits on the production floor where the operator or supervisor can monitor and control whatever is happening on the line. We also have a SCADA system sitting somewhere in the office area where the manager or the big bosses are able to also see what's going on the production line. Not just on the production line, they're also able to monitor some other processes apart from this direct production line. So the connection between the control cabinet, which controls this process, and the SCADA system, which monitors and having a bit of control process, is managed by the IT network, because the network that you use for the local running system is completely different from the network you use on the SCADA. Because in this case, you want to implement some safety, you want to implement some, let me say, you want to make some delineations between who can control what can be controlled. For example, in many cases, the person who is in front of the HMI has more control than whoever is sitting in the SCADA room, because the person who is with the HMI can physically see the process, is able to start and stop easily the process, can see what's happening directly, can see the effect of whatever control or whatever information is being given to the system. Whoever is in the SCADA room requires more information. Of course, you can see the system running on the screen, but you cannot physically see all the production line. So these are some of the things that are implemented in the control system themselves or even via the IT network. We will discuss that if we get into some of these things. So if there are no questions for now, again, I'll link up the link for this page, and I will always update this as much as I found more information. I will always update it, so keep an eye on this. So my idea is, after our PC hardware, go into the software where we'll do some hardware configuration. We'll talk about data types, tags and data types. Then we will do some PLC programming, introducing you to the programming languages. We'll do PLC simulation, because obviously many of you don't have a PLC right in front of you. We'll talk about timers and counters. Then we'll talk about libraries, GSD files, and probably as the classes go on, we might add more to this, but this is what I have for you for now. So thank you very much, and see you in the next video.